My pleasure to introduce Randy Graham, who will be leading the discussion on the modernized forecast process. Go ahead, Randy.
All right, thanks, Mike. Hey, good morning, everyone. Thanks for joining. Today, we're going to be talking about some things that we're doing in the modernized forecast process, and also with respect to key messages. You can see the name of the folks on the screen there that are part of the modernized forecast working group. Been working really hard, and we have, I think, a lot of exciting things coming up for the field over the next several months. One of the things we're trying to do is have these live briefings, weather briefings, and development of key messages on the fly, just like we have to do in real-time operations where we don't know the answer, neither do you. We'll go through some different kind of tools. Ginny Pittman's going to lead the tools discussion and kind of the weather briefing, and then Matt Friedline and Dustin Jordan are going to work on key messages as she does her briefing, and then we'll touch base on the key messages that they develop at the end of the weather briefing, and then we'll have some discussion on how maybe we can refine the key messages or what might be other ideas that you all have on what might be a good key message for the weather that Ginny talks about. So thanks for joining. Let's go ahead, Ginny, and move on to the next slide. So one of the things our modernized forecast process working group has been really focused on is the three things you see on the screen there. Today, we're going to start talking about the modernized forecast process and how what we're basically looking for as we step through using probabilistic ensemble tools is to identify messaging opportunities, not grid editing opportunities necessarily, but more about messaging and thinking about key messages as we step through these robust tools that we now have at our disposal. The second part of the effort from this group has been the modernized area forecast discussions, working with Central Region ISD on the supplement that was published last September. And of course, the two key parts of that were the key messages section and how to use our AFDs to discuss more probable and ensemble-based outcomes, most likely outcomes, viable alternate scenarios, and that sort of thing. So highlighted in red there are the two things we're going to talk about today, a little bit about the modernized forecast process and key messages. And then the third leg of that stool is a prob messaging effort and that's kind of working with the probabilistic messaging group to incorporate social science findings into our IDSS and our communications. So let's go on to the next one, Ginny, and then we'll talk a little bit about the forecast process. And everyone should be very familiar with the modernized forecast operation concept document. And in that document, Matt Jeglum and his peers out in the Western region, as they kind of develop this, had a four-step process here. Number one is assess weather and IDSS messaging. Number two is identify hazards and vulnerability and where they overlap. Number three, we changed the title here slightly. Matt, I see you're on the call. Identify messaging opportunities, because that's really kind of how we're focusing on the modernized forecast process. And that's what we're going to talk about during Jenny's discussion today. And then the last part is communicate it. And we'll obviously have a little bit of that in the key messages section at the end. So let's go on to the next one. And so this is kind of the idea of the process of going through the modernized forecast process effort. So you're identifying messaging opportunities, assess predictability and impact. And based on the assessment of your predictability and impact that you find, then what you're doing is in the lower right, there's kind of a scale, like the impact increases to the right on the x-axis and probability of occurrence increases on the y-axis as you go up. And the more those two go to the extreme ends, of course, you're increasing risk based on the vulnerabilities that we talked about identifying in step 2 on the last slide. But as you go through this process, you iterate and you keep going through different tools to try to identify potential messaging opportunities. And we're always should be thinking about message development. And so this is the kind of the general idea of how we're going to step through this process is to try to identify impact and probability of occurrence, and therefore assess the risk and then identify key messages from there. So that's kind of the big picture overview. And so with that, I will turn it over to Ginny to start leading the weather discussion.
Sorry, quick transition there. Okay, so I'm going to dive into just a general weather discussion following the modernized forecast process. And I also have Matt and Dustin from our team that are going to jump in if they want to add anything, as they're also writing the key messages. And I just wanted to start out mentioning that there are a couple of websites, both Western Region's Forecast Toolkit and then our ensemble and probabilistic guidance tools on the STI website, Central Region's STI website, that have links to all of this. So if you have either one of those resources available to you, you'll be able to find the things that we're looking at today. in case you don't have links to them already. So just starting out, kind of at the top of our forecast funnel, we're going to start out by exploring the forecast pattern and figuring out how to utilize what conceptual models we already have to start assessing what's going to happen, what possible impacts could be based on kind of a large scale pattern. So I like to use the cluster analysis for this for a couple of reasons. Not only that it's showing me a representation of more than just a deterministic solution, but that it's also starting to hint at predictability as well, because you're seeing the different clusters and where there might be some differences. But you can look at the mean, you can look at kind of these general 4 clusters and get an idea of what the overall pattern is, just looking at 500 heights. So we're looking at days 3 through 9. I know there's some sensible weather going on in the next couple of days with a severe weather risk today. Excessive heat through the plains, but we're going to look in kind of the days 3 through 5 period, and just beyond that as well, because we can start with this broader look. And this is where you'd want to start anyway. You want to have some forecast continuity over the last couple of days before you start diving into a lot of the finer scale details. So we're going to be looking at kind of this mid-range days 3 through 5. So we'll start out here at day 3. You can see ridging over the west. No surprise there that heat is going to be kind of the main concern with this pattern. And as we step forward, we do see that ridge broadens, moves east a little bit, but you see something interesting moving into the Great Lakes or the East Coast as well as you start getting into days 4, 5, and beyond. So this large scale pattern ridging over the west, and then eventually a trough starting to build into the east. Fortunately, not just working to reinforce that ridge over the west, you do see a little bit of a break in those anomalous heights over a couple of days, possibly mid next week, before that ridge really starts to rebuild a little bit further west. So that's our general pattern, ridging over the west, and then possibly some interesting things going on in the northeast over the next couple of days. But we're going to focus on that western part of the U.S., not just because Matt Jeglin's here. So in this stage, you want to look at the overall pattern, utilize your conceptual models, and also assess what should the predictability be in this type of situation. So this is a pretty predictable scenario, large scale ridge. You know that underneath it, it's going to be hot. Winds are probably going to be pretty light. And this isn't like a clipper or a snowstorm that's developing over the Four Corners region and moving up into the plains. This type of system should be pretty predictable. So obviously there are things that can go wrong at the local or mesoscale, but overall this is a pretty predictable pattern. So you want to kind of start your forecast that way of knowing what your expectations should be for things like spread for predictability. Let's see, Matt, did you want to say anything else about this one, or are we ready to move on to some other tools?
Yeah, I think we're good here. If you were talking to me, Jenny. Yep, I think we're good.
Sure. Awesome. Okay, so let's look at some other tools that we have. And we're going to start off with the ECMWF, and we're going to look at some standardized anomalies. So here we're looking at the mean geopotential height from the EC ensemble, and then standardized anomalies. And you can see the table here for the entire CONUS. So you can look at where some things are starting to stand out. But we also kind of know what time period we're looking at based on the cluster analysis that we already did. So we'll start 0Z on Saturday the 3rd, and just kind of step forwards. That would be around our day 3 time period. That's actually a little bit sooner. So maybe 12Z to 0Z Sunday is going to be similar to the period that we were looking at in our cluster analysis. So seeing very similar things, some anomalous heights, especially at the 500 level. But this allows you to also look at some of the other levels as well, just so that you can get an idea of overall pattern, what's going on. You could also look at wind speed if you were wanting to look at maybe some low-level jets or things like that. This obviously is in a closer period, but the only time that we really see a low-level jet. So you can also look at other variables here as well. You're starting to get into more detail, but still looking at a pretty broad pattern. You could also zoom in a little bit. This is just for the CONUS so that we're able to see all the different ranges of things that are going on. Maybe we're not just looking at the west. Maybe there are some other interesting things that we should be focusing on at this range. But when you're working in a local forecast office, you could obviously start zooming in a little bit closer to your area and getting a better idea of the pattern just in your specific portion of the region. So again, very similar to what we were seeing in the cluster analysis, and you do start to see these anomalies lessen with time. You don't see that in the numbers just because the table represents the whole CONUS, but as you start to look at some of the graphics, you can see that those anomalous heights are starting to lessen a little bit over the west as we go into the end of the weekend and early next week. So timing, overall pattern, and anomalies are helping you kind of focus in on what should you expect for anomalous heat and other sensible weather. So we can also look at the NAIFs as well. So this, instead of the EC, is going to incorporate the GFS and the Canadian. So it should look similar, especially in this more predictable regime, this more predictable scenario. But you can just double check, make sure there aren't going to be any big differences between different model cores and ensemble cores. You do see a little bit higher anomaly in the heights over perhaps the West Texas and the New Mexico area. But then as you move forward in time, you're going to see similar things where your anomalies are starting to drop off as you go forward in time. So hopefully not as extreme of heat as you move forward, and that pattern starts to become less anomalous, at least from a heights perspective. So this is just kind of a double check to make sure everything's lining up between different ensemble systems.
Hey, Jenny.
Yeah, go ahead.
Can you show the percentiles too?
Sure.
Just curious what those look like.
Yeah, there are a lot of options here too. If you don't want to use a standardized anomaly, or if that's not something that you typically look at, the percentile can help kind of zero in on how this fits within the climatology or within the model climatology. So here you can see like you're getting this max on the table, but it's actually almost off the side, possibly at 200 hectopascals. But if you go backwards in time a little bit, you'll see those max values be more in the CONUS, especially early into the weekend, like on Friday. So this is another good way, if you're not kind of conditioned to looking at some of the standardized anomalies, that the percentiles can help too.
And Jenny, just to remark on that, this percentile table can often have a lot of anomalies in the short term. It's not surprising to see that, especially on the national scale. But even if you go to the north central U.S., which houses a good part of central region, there's often a lot of anomalies in the short term. So you need to drill down a little bit then on the parameter and the various height levels there. And you can zoom in even to your CWA, as Jenny mentioned. But that's just with mid-latitude systems, there's somewhere at some brief period or some level that usually spikes to a upper percentile or lower percentile, depending on what you're looking at. So that's not a bad thing. It just means you need to drill down. But it is noteworthy if you see a big footprint, a longer duration, especially as you get beyond days 3, when you see that.
Yeah, for sure. And let's start drilling down a little bit. So we're kind of moving into step 2 of the modernized forecast process. We've got our forecast pattern, we've got our conceptual model, and we're starting to look at what we might expect for sensible weather. But now we're really going to use some of those machine learning tools, ensemble tools that we have available to us within this period. So some of the other things that you can look at, I'm back on the ECMWF portion of this page. So we could look at, I think I don't quite have the 0Z in, so we'll look at the 12Z from yesterday. I'm still not seeing it. But there is an M climate that you can look at, where you can look at the model climate from the EC. And that will help kind of give you a perspective of reforecasts and how this stands out, and why this is important, as you can start looking at some of those sensible weather things, like the max temperature. So this is not necessarily looking at, your 500 heights, your higher heights, or your elevated temperatures like 700, 850. Now you're starting to look at what might be occurring at the surface. So within this M climate anomaly, you can see some of those sensible weather fields. And so you can start seeing some things popping out, especially so we're looking in the Thursday time frame, nothing too anomalous for that max temperature, but as you get further into the weekend, you should start to see some anomalies for max temperature, and then also min temperature as well. You can see there. Let's see if we can go a little closer in time. All right, so you can see some anomalies in max temperature, especially over the west as you get further into the weekend. Not quite as high as what I was seeing yesterday, but this tool is at your disposal to be looking at ensemble reforecasts and how what the model is forecasting compares to that reforecast database. And I think this is really important with the GFS because if you noticed yesterday, the GFS was doing its thing with max temperatures and had 113 for Kansas City next week. So when you look at that reforecast, it gives you a good idea of how the model's comparing to itself, not necessarily how it's comparing to reality. But so you're able to look at, you could still look at heights here, similar to what we were looking at before, and just gives you kind of that broad picture of how that compares to the model climate. So still anomalous, we're just not seeing those really high values as we go into the weekend and the latter portion of this week. All right, and you can look at other things like the climate percentile. So that's going to give you more of those max values. So that's a little bit more useful, I think, than that anomaly, just because now you can tell where that falls within the database of reforecast. So it also looks a little more dramatic. So you're actually able to see where those anomalies, where this is becoming a little more common within the model climatology. It just sticks out better within this table, so that you're really able to see when maybe that heat would start to break after Saturday going into Sunday. All right, so lots of tools here. You could keep stepping through these, even return interval, to see how frequent some of these things should be from a larger scale perspective with heights, or from a sensible weather perspective with temperatures. So let's look at that return interval for max temperature. So this is the type of thing, especially in the West, that you should only see every, greater than every 10 years or outside of that model climatology, which is a period of 20 years. So that's why the 20 is listed here. All right, so let's jump to EFI. So this is the extreme forecast index from the ECMWF. And the other thing that's plotted on here is the shift of tails, so that you're able to see. So for those things that are falling outside the model climatology, like we saw in our previous graphic, how extreme are those things? So we're looking at similar information here. Does this fall within the model climatology within those ECMWF reforecasts? But then you also have that shift of tails to give you some information about those extremes and how extreme they might be. So we're looking at the West, we're looking at Saturday. This is actually the period from Friday through Saturday, so it'd be highs on Friday. And you do see some higher EFI here, so like you would expect from what we were looking at in the previous table. But then you also see a shift of tails of around 1 in certain areas over the West, and you can see that for Saturday as well. So the period from 0Z Saturday to 0Z Sunday, highs on Saturday. And you can see that some of those outliers are going to be pretty extreme. So not only are we reaching the edge of the model climatology, but we have some outliers that are pretty well beyond that as well, with that shift of tails of 1. We can look at other things here too. If you were concerned about severe weather, you could be looking at CAPE. If you're concerned about fire weather, which we certainly are in the West, you could be looking at wind speed. But fortunately, under the ridge, wind speed, at least non-influenced by local factors, doesn't look too anomalous under this big ridge in the West. So fortunately, we don't see a signal for these anomalous 10-meter wind gusts on a broad scale in the West during that period of extreme heat. So lots of different things you could look at here. QPF as well. We're looking at dry conditions and hot conditions, so we're not concerned about that. But QPF is also something that you could be looking at if you were more concerned about severe weather, or if we were focusing a little bit more on the eastern portion of the US during this period. And then finally, we have DESI. I'll mention that first portion of the forecast when we were looking at a broad scale. You could also use DESI for this. You can look at mean heights from the Grand Ensemble or from the NVM. So you would be able to get that broad scale look that we were doing with the clusters at the beginning. You could also use DESI for that. So lots of options there. But DESI does allow us to look at kind of whatever we want. We can look at broad scale. We can also look at fine scale. We can use some of the machine learning things. We can use statistics. There's a bunch of stuff that we can look at in here. And one of the things that you can look at, let me refresh it since it says I'm not reaching the DESI server. Probably logged me out. Okay, so one of the things that you can look at is apparent temperature, which is pretty hard to look at through some of the other means. So here you can look at your statistics, your spread, your timing, and probabilities for apparent temperature as well. This isn't quite as important in the West just because it's a little bit drier, but if you are in a central plains or eastern plains or even into the Midwest offices, this does become a little bit more important. And you can set thresholds, you can look at all sorts of things with apparent temperature. So we're just going to step through it just so that we can see kind of the mean apparent temperature as we go into these hotter periods. And you can see like the western, eastern portions or southern portions of Washington, we're starting to see apparent temperatures up to 100 degrees. But if we actually switch to temperature, and again, that's just the mean, it's actually higher. So what we're going to focus on in the West right now is actually those surface temperatures and not focus so much on apparent heat. But those are options that you can look at within DESI that it's just really difficult to find other places. I should mention, if you are following along, if you're forecasting, please feel free to post in the chat things that you would like to look at or things that you have looked at or would want to explore. And look at things that you would like to look at as well. So another thing that I'll mention is when you have these periods of heat, especially longer periods of heat. This one, fortunately, isn't looking too long. But if you're counting on several consecutive days for like an excessive heat warning or for concerns, shelters, things like that, you have to look for flies in the ointment because we've got this big, broad scale pattern, but things can happen. You can have thunderstorms develop, you can have anvil blow off from nearby thunderstorms. So there are other things that we probably want to look at as well, like cloud cover or precipitation, to see what could potentially be throwing a fly in the ointment of our heat. So let's take a look at some things like that. We can take a look at, let's just double checking to see if precipitation is going to be a concern. So we're just looking at mean, but we could also, if we want to look at our worst case scenario, there's any hint of precipitation in some of those ensemble members. So we can look at that through the period where we're concerned about that extreme heat, and we're kind of focusing on the Oregon, Washington, Idaho area where we did see some of those higher temperatures. I'm going to take off our sea level pressure. Some potential for perhaps some rain moving into the end of the weekend. So something to keep in mind if you were planning on some of this longevity impacting your high heat. To break down with possibly some precipitation later in the weekend. And you can also look at cloud cover in this aviation section of our upper levels and see what that looks like. So from a mean perspective, does look like some of the ensemble members or some scattered clouds. However, that mean is occurring there. Does look like cloud cover could be an impact on Saturday. Do see that starting to decrease later in the day and then returning possibly Sunday as well. So that looks like something that we want to look at a little bit closer, that we could have cloud cover during the day on Saturday when we're thinking that it could be pretty hot. And we'll look at our 90th percentile. So there are some ensemble members that are indicating that it could be cloudy during the day on Saturday. So something to keep in mind as you're thinking about messaging. And as this gets a little bit closer, is there going to be cloud cover around that could be reducing those temperatures? Some of the other things that you could look at. So we've just been looking at generally means. We've looked at a couple of 90th percentiles, but we can look at spread to get an idea of uncertainty. So let's go back to our 2-meter temperature, and we'll look at our 75th to 25th percentile and pick kind of a hot period, so Saturday, and looking at this area. So we were kind of focusing on the area to the southwest of Spokane and then the Boise area as well. So you can get an idea of spread here, about 6 degrees, so not real big. And it looks like your mean is what we were expecting, 101, 102, pretty much through this whole area. But your spread isn't huge. If you look at your 90th to 10th percentile, it should get a little bit bigger. You do see that 10th percentile, that 94, maybe a hint that there are some ensemble members that perhaps the ones with the cloud cover that do have slightly lower temperatures. So something to keep in mind. But in the Boise area, your 10th percentile being 98 degrees, or your 10th percentile being 93 degrees there, 94 here. So still hot, but definitely some possibility that perhaps an alternate scenario could occur during that period. And then I've always liked the 1D viewer, but you can switch over just within DESI. So let's look at Spokane and just kind of zoom in on that area. And this will also give you a really good idea of the spread. So just looking at the box and whisker plots, you can switch from the default to just a temperature perspective. If you want to look at the apparent temperature, again, it's actually a little bit lower than your 2-meter temperature. But this will give you a good idea of what's being indicated as the max, since some of those broad scale fields are like the 6-hour max, or you're maybe not getting quite the right time. This is actually pulling out the max T and showing you in the box and whisker plot. It gives you a good idea of not only what's being indicated within the ensemble, but what the range of possibilities are and how much spread there might be. And definitely it looks like that spread is really increasing as we saw those anomalous heights start to come down later in the weekend and into early next week. So still a possibility of heat, but it looks like our certainty is decreasing, and lots of lower values with that tail extending down even into the 80s for the high on Monday. And we can also look at Boise, since we were talking about Boise. Let's look what they've got. So pretty similar. Uncertainty starts to increase as you go into the latter half of the weekend, but definitely expecting at least one day in the hundreds, with a pretty tight box and whisker plot there, indicating that your confidence should be pretty high in those temperatures being reached. All right. So other things we can look at, if you've got your Weather Bell subscription, you can take a look at Weather Bell. And one of the things that I like to do is the meteograms, just because this is a good way to just visualize some of the spread and also what the different ensemble members are indicating. You have to look at either the EC or the GEFS. They're not combined in this case. The EC, and look at max temperature for all the different members of that model, and then it's also nicely plotted into your box and whisker there too. This is over a 6-hour period, so you'll see some overlap there where the high is being reached at some point between those periods, between 18Z and 6Z. But just kind of a nice visualization. You can see the numbers are all pretty similar and pretty much all right around or slightly exceeding 100 degrees. And this is for Boise, and you could change to Spokane or any other location that does exist within here. And then you can change to the GFS ensemble, do kind of the same thing. Looking at max temperatures, and you can change the run as well. You can see there's a lot longer run here with the 60 and the GFS. You could have changed the EC back to the 0Z as well to get kind of this longer range. And you do see what you would expect as you go further into the forecast period that there's a lot more uncertainty. But it's a good way of just visualizing and looking at what the model ensemble members are indicating and how close they are to each other. So at this point, we're starting to assess our potential messaging opportunities and continuing to zero in on our confidence and our predictability. So we started doing that with DESI, exploring the spread. We talked about the things that could go wrong, cloud cover precip, things like that. And zooming in with the 1D viewer within DESI is really helpful as you're starting to figure out those messaging opportunities. Now, if you work in Boise or you work in Spokane, you know if 100 degrees is a big deal to you. But you're also going to have partners that have specific thresholds too. So you'll want to be able to look from a broad scale or from a finer scale and maybe set that probability of exceedance, figure out what's important to you within your forecast area or to a specific partner. And you can use DESI really well for that. So let's go back to our 2-meter temperature. Let's go to probabilities. And let's say that 100 degrees is what's important in our forecast area. And we're going to switch the window to 24 hours just so that we're not limited by timing. So you can already see for Saturday that we have a pretty high probability, at least a high percentage of the ensemble members that are indicating that the temperature is going to be greater than 100 degrees at some point on Saturday. And if you scoot forward in time, you can see it doesn't move because we're looking at this 24-hour period. So really pretty high probability and pretty high number of ensemble members that are indicating that we could get above 100. If you did want to look at apparent temperature instead, again, this isn't going to be super important out in the West, but something that central region offices especially would be looking at for like if we're going to exceed heat index criteria. So let's do greater than 105. And we'll move our window again to 24 hours. And we'll zoom out a little bit just because as we looked at before, the apparent temperature is going to be a little bit lower than the air temperature. But this is the type of thing you could do if you're looking for, am I going to exceed heat advisory criteria? And even though that's not what we're talking about, we'll go back to kind of the current period so that you can see the Central Plains, Kansas City, Wichita, Oklahoma City areas, and what that would look like if you were looking at an extreme heat advisory type scenario across the Central Plains. So these are just the different thresholds that you can set. Again, you want to know what's important to your partners, but you also do know what's important in your CWA and what might be impactful kind of on a broad scale. And if you have partners that have a specific temperature that they would open cooling shelters, and maybe that's going to be a minimum temperature above 80, we can look at that. We can look at in that 6-hour window, would that minimum temperature stay above 80 degrees? And that's what's important to them in that case. You can look at that. So lots of possibilities here within DESI. I actually think the best way to do it would be less than 80. Let's see. So we can see what the probability is that our low is going to get below 80. And out in the West it is because it's a little bit drier, but that's the type of threshold that you could be setting for cooling shelters. Maybe 70 is the magic number. So just seeing, is there any probability that it's going to get cooler than 70 during the overnight period? And as we go into that higher heat period, you see that some areas within, let's do a 24-hour window. Some areas may not get below 70. And again, that's a threshold that you would know from your partners and would be able to look at. So finally, we're going to look at how we can provide context to this. So we've looked at the scenarios, we've looked at their predictability. Now let's provide some context and look at some of the other tools that are at our disposal. So we have heat risk, which is going to be looking at your max and min temperatures and how that compares to climatology, which is important because it can be different times of year. Everybody in this area is like, well, it's Kansas in July, it's 100, we're used to it. But if it was June or in the West, where maybe 100 isn't as common, heat risk kind of helps provide some context to that, and also helps provide some context with duration. Where you see those purples showing up is where you have a longer duration of that extreme heat. So this is a tool that's also at your disposal and can kind of help just confirm what you're seeing. You're seeing these purples southwest Spokane, you're seeing them in the Boise area, and also a very broad area of red. So that's telling you not only is that heat anomalous for this time of year, there is that component of longevity as well. So that's a tool that's at your disposal, not only for messaging, but also for your own edification. And then one last one to look at, the National Blended Models forecast records, just a good way of paging through to see, again, compared to climatology, compared to the past, how does this line up? And you can see if there's a possibility for some records to be broken, which would be a messaging opportunity and also gives you kind of that historical and climatological perspective. So that is all that I prepared to look at over the West. Any comments, anything that you want to add from the Modernized Forecast Process group or from those that are listening in? Anything that you want to look at that we didn't look at?
Somebody shared a link in the chat there, Jenny.
Let's see if I can click on it. Yeah, that's a good one also. So Ben Sapral put this in the chat. You can look at what we're currently forecasting in the NDFD and how that departs from climatology as well. So we can start looking into that extreme heat period and see that compared to climatology, we're looking at high temperatures greater than 10 degrees above the climatology for that period. Thanks for posting that, Ben. That's great. Another good context tool.
And while convection didn't look to be a striking issue here, Jenny, in the period you looked at, a reminder of the CSU machine learning probabilities here in this period. Maybe we're going to get to that here. So yeah, just that's always a great thing for that days 3 through 8 type period.
Yeah, I didn't show it just because there wasn't a whole lot for that period, although we are looking at some potential, at least, especially across the eastern half of the U.S. So this is definitely something that's worth looking at and using that machine learning information to help us broadly look at the severe weather risk, and then we can kind of zoom in with other tools after that point. And Matt, you had also shared, I don't know a lot about SHIELD, so I brought it up, but I thought you might want to talk about it, which is another tool if you're looking at precip or storms.
Yeah, I think Ryan Sharp from the Louisville office may have had a CR speaker series on this one in the past couple of years, but it's a convection allowing model that runs out to 5 days, 120 hours. So obviously, domino effect, it can be fraught with peril in solutions as you get way out there. But if confidence is high in a stormy pattern, it may give you ideas on a regional scale or even kind of multi-state scale on general convective mode, maybe footprint of what convection might look like if you're more confident in occurring. This is not the scenario, obviously, that we're looking at here of high confidence, especially as we get into a lot of central region here for early next week. There's not much there, but yeah, that can help with that predictability signal, depending on what type of mode you may be seeing out there, and also degree of magnitude or impact. If you're seeing a strong signal for MCSs, like we've had in the Corn Belt here the past couple days, or if you're seeing more spotty activity, it can give that kind of proxy for that.
Great. Yeah, and I pulled up just the western portion of the US because that was one thing that we were looking at. Is there going to be precipitation possibly? And then, how widespread is it? Is it just going to be spotty showers that maybe one area is going to be impacted, or does it look pretty widespread? And could it have an impact on that heat? All right. Well, I think that's everything we want to look at. So I can bring the PowerPoint back up, and we can start talking about the key messages that you guys were able to come up with.
All right, great job, Jenny. Thanks for the briefing and putting all those tools in context. As I mentioned at the top, one of the things that is in the modernized forecast process is you go through the exercise that Jenny was just doing. You start thinking about key messages and opportunities to share information and key messages with partners in the public as you go through that process. So just as a refresher, the main objectives of the key message is to communicate the main points of your forecast, of course, be very concise, articulate relevant weather, water, and climate information and their impacts without using jargon, raise awareness to upcoming potential events or alternate scenarios, describe the evolving the threats, that sort of thing. But you really want to focus on the hazards and the potential impacts, not storm details. And we don't want to get into a low pressure is forming here and moving to there kind of thing. You want to just get down to what the impacts are. And some of those tools that Jenny described, the impacts are very evident, like the ECMWF EFI data is very impact based, whereas anomaly information, for example, you're finding out anomalous variables in the atmosphere, but they don't speak directly to the impacts. And that's where your expertise comes in to be able to infer the type of impacts based on the anomalous forecast that we see from the ensemble output. So during this discussion, Dustin and Matt have been working on developing some key messages. So we're going to turn it over to them and have a little discussion about what they came up with. So Dustin and Matt, take it away.
All right, thank you. Let me see if I can get this shared. Matt, I'll share it if you want me to there. All right, there we go. Well, you guys can see what we came up with there with, and Matt, I'll take the first one if you want. And I know Matt's helped. We kind of both put this together just as we were talking, and kind of the first bullet is just kind of talking about our confidence level, right? So we saw all the different tools that we brought up, all the different things, and a lot of confidence in heat building across, like we talked about throughout the discussion in the Front Range, High Plains, as we get into early next week, and even including some near record highs and things in there, so you can kind of talk about that, bring some context into this higher confidence level of seeing heat build this weekend and into early next week. And if you notice, we talked about high confidence, but we also wanted to put context with that high confidence. So putting in the 80% or greater just kind of puts in that probabilistic information, so you can kind of put a frame around maybe a word of estimated probability or something like that. So that's what we talked about there in the first bullet. And Matt, do you want to take the second one?
Sure can there, Dustin. And this was taking the first one that Dustin noted and sort of drilling down a little bit in terms of magnitude and that scenario. Is there any potential scenario for an extreme event, and quantifying the magnitude of heat some. We thought the heat was a striking enough forecast note that it was worth two key messages there, and this one with a little more detail there. So as Jenny showed on some of the duration elements of the heat, whether it be the spatial ones in DESI, or even at the very first, the pattern in the pattern breakdown there a little bit in the Intermountain West early next week, or drilling down to points too, all of them showed that the duration of the heat may not be on the extreme end there, but there would be triple digits there this weekend with pretty high confidence, as she showed with the point data from Spokane and Boise there. So we weave that into this second message here. Dustin and I had to real quickly learn some Western geography with the Snake River Valley there. I won't say if I use Google for that, but to try to quantify some of the probabilities there too. And sometimes we want to use caution in having too many probabilities in a key message here. But this one, we probably spent the most time on trying to craft in that. And so we've got that kind of extreme scenario mentioned that looks low based on some of the record duration and that information that looks lower. But the triple digit, that threshold there, that looks like that's going to be met this week, and including in a couple cities there, Spokane and Boise. So that's sort of how we crafted that second one, but certainly welcome any input or suggestions, like I said, in the chat, or maybe at the end here, we'll open it up for questions and suggestions. And on the third one here, Dustin, I can take that one here too, and
Sure.
let you chime in here at the end. On fire weather in the West too, we're kind of learning on that. Greg from Boulder provided us some local insights yesterday too on that, but certainly a hot pattern. So that sort of flips the switch to drill into potential fire weather concerns there. And while there certainly could be localized effects where the winds are higher with the Intermountain West and on the Front Range, as a whole, when Jenny looked at the signal for winds, that was on the lower end, both on the anomalies early on and then looking at some of the data in DESI too. So we sort of phrased it like that: the potential for widespread fire weather concerns is low. And now again, there are likely some local effects there in the West in this time of year, climatologically, where there'll be some issue with that warmth. But on the widespread scale, there wasn't a striking signal for that, given that wind component being lower. And Greg yesterday stressing how wind's really a big deal on the Front Range. That really is the main element there for fire concerns. Anything, Dustin, you wanted to add on that?
No, that's great. Yeah, like you said, the higher winds. This was a little bit harder to craft, like the fire weather concern, because it was a little bit on the lower side. And of course, I'm not as experienced on the fire weather front out in the West, but definitely not a lot of signal there in the EFI either. Just looking across much of the area, there wasn't a strong signal for higher wind gust in that period. So definitely why we went a little bit lower probabilities on that area. So yeah, that's I think you summarized it really well. So yeah, any questions? I guess Jenny or Randy, if you want to take it back over, but yeah, any questions or any thoughts on our key messages? We're doing these on the fly, so we're always open to open to suggestions.
Yeah, if anybody has any comments, just type them in the chat or raise your hand. These are really good. I really liked how you include the percentages in there, of course, to really convey the message more effectively and get away from using those WEPs where people are interpreting the words in their own manner and putting their own error bars around the words that we use. So I think that's a really important component of the examples that you shared, is that you put the percentages in there, which is really valuable. So if anybody has any comments or suggestions on how to improve these, raise your hand or type them in the chat. But that's a good link, Ben. All right, so nothing seen. Let's go ahead and wrap up, and we're just going to talk just real briefly. I'm just going to share a few things that are going to be coming up from the Modernized Forecast Process Working Group. So we're doing this live guest speaker series. We're going to have another one in 3 weeks on August 21st. We'll do another one in September. And again, it'll just kind of be based on what the weather is at the time. And I think as we get further into these live discussions, we're going to move more into depth, I should say, onto the Modernized Forecast Process. We're going to have some training material, some vignettes. There's going to be 10 short vignettes that are going to come out. We're targeting mid-September for those. They're going to step through each phase of the Modernized Forecast Process. We'll likely do a presentation at the Fall Symposium. And then one thing I'm very excited about is probably in November. We're going to try to do these communities of practice discussions where we're going to get together with forecasters as much as possible. I'm not sure how many of those we're going to do, if we're going to do 6 or we're going to do 8 or something like that. But we're going to have some discussions based on modernized forecast processes and key messages and that sort of thing, and just get in some Google Meets and have some small group dialogue type things. So there's a lot coming up from this group, and looking forward to it. And so we will end the call here for today. Thanks everyone for joining, and have a great Wednesday.